So again, in the handout, you will see there's all kinds of different examples that I have included just to show you, how to create different Venn diagrams, how to use the Venn diagrams to help us solve some of these questions. So if you look at some of these examples here, and we had done something similar to this example, in example 4. But you can see just all the different types of examples. They've got you, giving you some instructions over here. One of the other type of examples we'll be looking at is, when you have 3 overlapping circles and how to solve those kind of problems. And, the idea is you can actually have many overlapping circles. So there are actually in your textbook, I don't have that included in your homework, where they've got, like 4 and 5 different overlapping circles. And then, you're kind of trying to break them down. So for a lot of these, I would say especially when you guys are working through homework, look at the handout, because you will see there's a whole bunch of different examples to help you solve, especially with these 3 overlapping circles or more, that you can use to help you solve your questions. And then, of course, we'll get into De Morgan's laws. We talked about these in the logic section also, so we'll come back and look at these in context with set theory as opposed to logic, but just all kinds of different examples that you have in here to help you out. So I just kind of wanted to point that out, but let's go ahead and take a look at a couple more examples before we get into De Morgan's laws. Okay, so I'll leave this guy over here and let's go into our exercise over here. And how about we look at let's do number 16 from section 2.2. Okay, so trying to make this big so you guys can see this easily. Okay, so this one is talking about after leaving the polls, many people are asked how they voted. So, this is your exit poll. So they are talking about concerning propositions A, B, and C, the following information was obtained. So they're telling us 294 people voted yes on proposition A. 90 people voted yes only on A. 346 voted on B. 166 voted yes only on B. 517 people voted yes on A or B. 399 voted yes on C, and no one voted yes on all 3. And then they're telling us 72 voted no on all 3. So since you can see we are talking about propositions A, B, and C, this is definitely going to be an example on 3 overlapping circles. So let's go ahead and take a look at what the circles might end up looking like. So let's get into our, oops, sorry. Let's go ahead, clear this out, get into our notebook here. And this guy is number 16. We'll start with, whatever information we have on hand. So this will be our universal set. And then we'll go ahead and do our, 3 overlapping circles. So let's see if we can move these guys. And we'll do one more. So just kind of a general, idea for what those 3 overlapping circles will end up looking like, right? Now we can label these, for each one of the propositions. So you can think of this guy as being, and you know what, let's use a different color. So this can be for proposition A, proposition B, and proposition C. Okay, now let's take a look at all the information that was shared for us. So this is the information they obtained. They're telling us 294 people voted yes on A. So remember, that means the 294 people is going to be everybody who falls into circle A, right? So that's 294 who voted yes on A. So remember, that's going to be this area and these three overlapping regions also. So all of that together has to add up to 294. So there's really no place in the overlapping circles where we can put 294 directly. So does that make sense what the 294 stands for? Okay. So like I said, we're not quite ready to place the 294 into our circles yet, but we know that's what the total for circle A has to come out to be. Then they are telling us 90 people voted yes only on A. So that means your 90 people who voted yes only on A is actually going to go right here in the non-overlapping section. Because think about it here, and I'm going to again try for a different color. Let's do brown. So this one over here, this section represents people who voted yes on A and B. This little section here represents the people who voted yes on A and C. This section here represents the people who voted yes on B and C. And then the very centermost is for people who voted yes on all three propositions. So that's kind of what these overlapping sections mean. So when they're telling us 90 people voted yes only on A, that's why the 90 people go in this outside circle and not in any of those overlapping sections, okay? So this is kind of how you have to break down, the information that you are seeing given to us in the problem. Then they are telling us 346 voted yes on B. So again, that 346 is going to be entire B circle. So we're again not ready to put that number in. So let's see, 346 voted yes on B. They are telling us after that 166 voted yes only on B. So the 166 is going to go again in this outside part of circle B because these are the people who only voted yes on B. 517 voted yes on A or B. So 517 voted yes on A or B. So again, we will kind of have to see with a little bit of calculation how we're going to break that information down. So again, we're not ready to place it inside of our circle. They're telling us 399 voted yes on, 339 voted yes on C. Then they are telling us no one voted yes on all three. So that actually means nobody voted yes on all three. So our centermost is actually going to be a 0 because nobody voted yes on all three propositions. Okay, so that's where the all three goes. And then they are also telling us the last thing, 72 people voted no on all three. So where do you think those 72 people who voted no on all three is going to go?
In the universal area.
Yeah, very nice. So those are the people, since they are not part of any proposition that they voted yes on, those 72 people are actually going here on the outside of the circles. So now what we have to do is basically we need to fill in, all of these empty spaces. So that is going to be this section here, these two overlapping sections here, and then this section over here. So this is where I was talking about, some of that math is going to come into play. So the way we are going to do this, and I'm trying to think what would be the best way to approach this. So we know, you know what, let's label these empty sections over here. So let's call this overlapping section here X, Y, and Z. And you know what, since this represents proposition C, we'll just call this section C over here. Okay, so now think about the information we have on hand. They are telling us the total of number of people who voted yes on A. So if you look at the circle A, you know, of course, we know there's 0 right in the middle for all three. So if I take my X and Y sections and add the section that has the 90 people in it, all three of those numbers have to add up to 294. Do you see that? So everybody who falls into, and you know, if this centermost number had not been 0, but something else, we would have included that as part of our calculation. So technically you can add that 0 in here, but you know, of course, adding 0 does not make a difference. So that's why we're not including that 0 in there. So if you think about it in that same way, if you look at circle B, we can take the section X plus Z plus the 166. And we know for B, our total has to come out to be 346, because that's how many people voted yes on B, right? So those will be the two, you know, A and B proposition circles. And then let's take a look at, they are also telling us 517 people voted yes, you know, on A or B. So actually, if you look at the total between the two A and B circles, that would be X plus Y plus Z plus the 90. So I've got X, Y, Z, those are my overlapping. We don't need to include the 0. The 90 and the 166 have to add up to 517. So right now we're just, you know, trying to come up with our equations, and then, you know, we'll solve those equations to find out all the missing sections over here. We don't really have a whole lot of information as far as circle C goes. We know that's a total of 339 people. So, you know, that would, of course, be the sections of C plus Y plus Z, which would have to add up to 339. So, you know, obviously all of those are unknown, so we're not quite ready to get to that part. And I think those will be our 4 main equations, because that takes care of A, B, and C. And then since we know the total between A or B, we added those up also. So let's clean up these equations a little bit. So let's start with the first one, and I'm trying to place this. I guess let's do this guy over here. So we've got X plus Y plus 90 equal 294. So let's clean this up. And all we're going to do here, guys, is take that 90 and, you know, subtract it on both sides so that we can move it to the other side of our equation. So go ahead, subtract that 90, move it to the other side, and we will end up getting, you know, so this side will cancel out. And we are left behind with X plus Y equals, what will that be, 204? And let's call this equation 1. Let's see, our second equation is for circle B. So that's X plus Z plus 166 equals 346. We'll do the same thing, subtract 166 on both sides, clean this guy up. So again, 166 cancels out on this side. And we are left with X plus Z equals, what will this be? So 346 minus 166 will end up giving us, what's that? 180. And we'll go ahead and call this equation 2. And I guess we can actually clean up the equation with the 517 also, because we've got x plus y plus z. And we can actually go ahead and add the 90 with the 166 here. Just trying to clean it up, as much as you can. So these guys add up to 256 here. So that can be plus 256. And then, of course, just like we did with the others, go ahead and subtract that number on the other side. So 517 minus 256 will leave us behind with 261. And we can call this as our equation 3. So does anybody remember how we solve system of equations? Where you have two or more equations in the same system with two or, more unknown variables. Just anybody have an idea? Remember that? All right, so remember, we're not quite ready to tackle the fourth equation, which is coming from c plus y plus z equals 339, because, obviously we don't know c, y, or z at this point. So we will actually have to solve these first three equations that we have here right now. And then once we come up with c, y, z values, then we can go ahead and tackle that last equation. So let's start by looking at what we have over here right now. So we've got x plus y equals 204. We've got x plus z equals 180. So can we combine, you know what? The way I'm looking at this, we can either combine equation 1 with equation 3 or equation 2 with equation 3. So this is kind of what I'm thinking. So let's maybe look at first and third equation here. Okay. So let's see. My first equation is x plus y equals 204. My second equation, third equation is x plus y plus z equals 261. So if you think about this, we are saying x plus y is 204, right? So I can actually use that over here, because then I can take my x plus y over here and I can say this equals 204. So you're basically taking the first equation and bringing it into the second one. Do you guys see what I'm trying to do here? Anyone who does not? Because, you'll have to do this in your homework assignment. So I just want to make sure everybody's on track with me. Okay, so since they're telling us that x plus y equals 204, we're literally taking x plus y over here, and we're going to replace that with 204. So then we can say, so we can basically say 204 plus z equals 261. And then this way we can come up with that z value. Go ahead and subtract that 204 on both sides. Of course, these guys cancel out here, and then you come up with your z value. So can you tell me what our z comes out to be?
57.
57, all righty, very good. So let's see, 57 plus 4 will give us 61. Yeah, wonderful. So we have our z value, which is 57. So we can now come back to our circle. And you know what? I think I'm going to use purple to write these in so we know we are filling in these spots. So z goes out. and you can replace that with 57. Oh, what happened to my pen? Alrighty, so we've got one space filled in. Now we need to work backwards and find the others. So now that we have our Z value, where do you think we should move next? What can we find next looking at those equations that we have? 1, 2, and 3.
Number 2.
Number 2, very nice, Logan. So you guys will see that we have number 2 as x plus z equals 180. So now that we know the value of z, we can calculate x. So x plus z equals 180 is going to be our next one. So this time we are going to substitute for our z with 57. Same thing, subtract that 57 on both sides. And what do you end up getting for x?
289. Oh, wait.
No, you're subtracting.
I know, I messed up.
That's okay. So 180 minus 57 will give us what, guys?
123.
All right, very nice, Adali. 123. Okay, very good. So 2 down, 2 more to go. X is 123. So coming back to our circle over here, let's go with, ooh, I don't have enough space. 123. All right, so now we have X and Z. So where do we go next, guys?
Equation 1.
Equation 1, very good. So we can find out what the Y value is this time since we know the X value. So X plus Y is 204. Okay, very good. So X we know is 123 now. So 123 plus Y is equal to 204. Same thing, subtract that 123 on both sides. And what are you looking at for the value of Y?
81.
All righty, Roman, very nice. 81 for Y value. Okay, so 81 will go in here. Okay, let's see. And now, as you can see from our Venn diagram, the only thing we need to complete is the C value. And where do you go for the C value?
The 339.
Yeah, the very last equation. So right over here, let's call this equation 4. So we have to use equation 4 for that. So that's C, Y, and Z is 339. So C, Y, and Z is 339. Our Y value is 81. Z, I think, was 57. There we go, 57 for Z. So go ahead, do the calculation and let me see what you guys are getting for, the C value. So, do the math, get the C by itself like we did with the other equations. And when you have your answer ready, let me know.
Are we putting it in the chat?
Yeah.
Okay.
So when you have your answer ready, I think most of you guys are done. So go ahead, send your answers to me. All righty, very nice. Ethan, Roman, Nicholas, Logan, Cynthia, Idali, Ashley, all righty. So yeah, again, you know what you guys can do is, oops, sorry, add up your 81 with 57, which will come out to be, what is that, 138? And then subtract that 138 from 339. And you know, of course, you can do 339 minus 81 minus 57 also, and that still works. And that will end up giving you your 201. All righty, come on, buddy. Okay, so now that we have all the values for our Venn diagrams, you know, we filled up all the empty spaces. Now you can go ahead and answer these questions. So part A, they want to know what percent of the voters in the exit poll voted no on Proposition A. So since they're asking about what percentage, we actually have to first find out how many total voters, you know, were asked this question, or how many were polled as they were leaving. And you will see in the information they gave us, they didn't really tell us how many people they asked the question about, you know, how they voted. So we don't really know the total number of people. So what do you think we need to do to find the total number of people who were, you know, asked the exit poll? Because now that we have our Venn diagram, you know, we can find that, but what will we need to do?
Add everything up.
Yeah, so you will add all the individual sections of your Venn diagram. So to get the total number of people, let's call them total number of voters. So that will be the 72 on the outside. And then, you know, take all the circles. Now, remember, be careful about using these 294, 346, 517, or 339, because remember, they have those overlapping regions in them. So you don't want to count the voters, you know, twice or three times over. So what I do is look at all the individual numbers. So you've got, let's start with circle A. We've got 90. Then we have, you know, the 81 and the 123 in the overlapping areas. Of course, we don't need to count the 0. Then if you go to circle B, we've already got the 123. So we can take the 57 and the 166. So 123, 57, 166, that's B. And then if you will see from circle C, we've already counted the 81 and the 57. So that really just leaves you behind with the 201 at the bottom. And that will be your total number of voters. So just be careful about not counting, you know, twice or three times the overlapping regions. Yes, Idali?
So I have a question, like, for example, 123, why are we counting that into the total number of voters? Because wouldn't it be people who just voted for both A and B?
Yeah, but they are still your people who were asked the question, who were polled, right? So even though
Oh,
they
wait, never
voted
mind,
for
I got
both
confused.
A and B, you still have to count them in your total, right?
Yeah,
Okay,
I
good.
confused myself.
Oh, okay, no problem. Yeah, we're not
Thank
quite
you.
ready to answer question A just yet. We're just asking the total number of people who were asked these poll questions.
Okay.
Okay, so did anybody get a total on our voters? Do you have your grand total? All right, I'm seeing an answer showing up. All right, Cynthia, so you're adding that up to a total of 790. Can anybody else just confirm that number for me?
I got 790 as well.
All right, awesome. So that works. So our grand total for number of voters is 790. Let's go ahead and put that down here. Man. Okay, 700. Sorry, that should be a 90. Will it not let me do that? I guess not. Okay, so 790 for our grand total. So now let's answer our questions A and B. Okay, so let's take a look at it one more time. What percent of voters in the exit poll voted no on Proposition A? So yeah, as Adali was saying, obviously we cannot include the 123 in that. So can you tell me the total number of voters who voted no on Proposition A? And also tell me how you came up with that answer. So how many people voted no on Proposition A, and how do we come up with that answer?
I got 496 and I added up B, C, and the overlap and the universal 72.
Okay, so what numbers did you leave out?
A 90, 81, and 123.
Very good. Yeah, exactly. So that's, obviously because all of those people have voted at least once on Proposition A, right? We know the 90 people only voted yes on A. We know the 81 voted yes on A and C, but obviously they voted yes on A, so they cannot be counted. Same thing for 123 because they voted yes on A and B, so they cannot be counted either. So everyone who's not in circle A gets counted. So honestly, what you guys could have also done, you said 496. So, you can add up the 90, 123, and 81, which of course will give you the total of the 294 that we know voted yes. So honestly, you could have done is just taken the 790 and subtracted the 294 from it also, and that would have worked. So multiple different ways that you can come up with this. So we know 294 people voted yes on A. So basically you can see voted no on A would then basically be the total minus the 294, which was, remind me again, I think you said 496. Okay, alrighty. So once you have this number, guys, to find the percentage, you are literally just taking 496 and dividing it by the total number of voters, like you would find any percentage, and then, come up with your answer this way. Now, by default, you are going to get a decimal answer. So to convert that into a percentage, you can either multiply by 100% or move your decimal 2 places to the right. So can you tell me what percentage do you see coming up for this? 496 divided by 790 will give us what?
62.7.
Alrighty, so if you just, plug this into a calculator, man, I changed the battery on this and the pen is still not wanting to do. Okay, so just your raw answer, guys, when you just put this in the calculator will come out to be 0.627848, and it keeps going. So to convert this into a percentage, let's see, did they give us any rounding rules here? Not really. Well, let's just go ahead and do 1 decimal place, and then you can see if there are any specific rounding instructions in your homework assignment. So if we want to go to 1 decimal place, first thing we'll have to do is convert this to a percent from a decimal. So you will need to move your decimal point 2 places to the right. And then since you have a 7/8, that will actually round this guy up to 62.8% because you will, of course, go up by 1 unit. So 62.8% of people who were polled did not vote yes on Proposition A. That's basically what they're asking us over here. And then we also have a part B, and this one wanted to know what percentage of the voters voted yes on more than one proposition. So again, read that question. What percent of the voters voted yes on more than one proposition? So, what do you think that number would be? And let's start out without the percentage. Just give me the raw number of how many people voted yes on more than one proposition. And how do you come up with that? How many people voted yes on more than one proposition? Okay, what do we have? Okay, if you don't answer me, then I will start calling out your name. So somebody's got to tell me. Ethan?
Yeah, I added 123, 81, and 57 together.
Very nice. Yeah, because you got to look at the overlapping regions, right? To see how many people voted on more than one proposition, because the 90, 166, and 201 only represents one yes vote for that particular proposition. So very nice. For part B, you will be looking at voted yes on. All right, very nice, Cynthia. The total you gave me is 261. Voted yes on more than one proposition. So 81, 123, and what was that last number? 57. Okay, so that's a total of 261. So same thing, guys, for your percentage. You take the 261 and then divide it by the total number of voters. And what kind of numbers are we looking at here for this guy as a percentage?
0.3303, and then it continues on.
Okay, so obviously it's going to be a smaller percentage because your number of people is 261. So 0.33, let's see, 0.379. So again, if we just round it to 1 decimal place, you are looking at 33.0%, because you've got 0.3 after that. So this is how you calculate your percentage. Now, some questions will ask you for a percentage, and some may just say, how many people or how many, whatever. So they may want the 496 as the answer in part A, or if they ask you for the percentage, that's a 62.8. Same thing for part B. If they ask you for the number of people, then you're looking at 261. But then if they ask you for percentage, that's your 33%. So just make sure you're reading the questions correctly, just to see if they want the percentage or the number itself. So that was just one example to kind of show you how these three overlapping circle examples work. So anybody have question on this example that we just looked at? So you will have a couple examples like this in your homework, where follow the same process that we did here. Some of them may be a little bit easier than what we looked at, but if you can use this idea of how we did the equations by labeling our different regions, and just for reference sake, I will go ahead and put our letters back in so you know which represented what. So this was X, Y, Z, and then this guy was C over here. So when you go back and reference this, you will know what regions we were talking about. But these equations will really help you out to simplify your problem, because then it makes it more of a mathematical problem than trying to say region A or region B or that kind of thing. So assigning these variables actually makes it a lot more easier to then break down your different sections, and you can see how we came up with those numbers in this example. All righty, guys, how about so this is what I wanted to show you. Now, you don't have examples like this, but you can see how they actually have 4 overlapping circles here, because you can see the A, B, C, and D. But look at how many different overlapping regions this ends up making. Like you've got, this is just between A and B, but then here, this little sections is A, B, and C. And so you can see how many different overlapping sections you end up getting between these 4 circles over here. Of course, this is another overlapping section here, and then these are individual sections, and then something on the outside. So the more overlapping circles you have, the more these regions are going to multiply depending on how those circles are placed. So definitely, we're stopping at 3 regions, but there can be more circles, but there can be more that you have to work with. All right, guys, so I wanted to point out how these De Morgan's laws translate from logic into our set theory. So if you look at the laws themselves, they're listed out over here. So you can see here, we're saying for any sets A and B, if you are looking at the complement, because remember that little prime mark represents the complement of a set. So kind of like, the negation we were talking about. So this is the complement of A union B, and it is equivalent to the intersection between the complement of set A and complement of set B. So basically what happens is, if you're doing the complement of the union, you basically end up taking individual sets complement, and the union changes to intersection. And if you use that same logic, when we are looking at the complement of an intersection between 2 sets, which is the second formula here. Come on, there we go. So complement of the intersection of 2 sets ends up becoming, the complement of each individual set, and the intersection changes to a union. So basically, your intersection and union will switch, and then you will end up taking a complement on each individual set, whereas, on the left-hand side, you had the complement on the union or the intersection. And these were some really nice examples that your textbook had on just kind of showing you how set theory works out in real world situations. So I definitely ask you guys to kind of look over these examples over here, just to kind of get an idea of how set theory actually looks like in real world situations. So let's take a look at this example over here, guys. Just get a little bit of practice with this De Morgan's law. So we are looking at number 24. And of course, this is a little bit of a modified example than what the straightforward De Morgan's laws are. So our universal set is defined as the set going from digits 0 to 9. Set A is defined as 0, 2, 4, 5, 9, and set B is defined as 1, 2, 7, 8, 9. So they're asking us to use De Morgan's laws to find this set, and this is the example we're working on. So if you just look at the basic De Morgan's law that we just went over. Okay, there we go. So our question is A complement intersected with B, and then, of course, you're taking the whole complement on that set. So right now we're looking at the intersection between set A complement and set B, right? So just to get an idea of what De Morgan's law on intersection is, let's take a look here, which is the second one over here. So intersection breaks down into, A intersect B, complement on the whole thing. And then it translates to, or is equivalent to, A complement union B complement. So let's write down just the basic rule for now. So A intersected with B, and then you have a complement on the whole thing. This is equivalent to A complement union B complement. Okay, so this is your original rule. Now let's translate that into our example. So our example is A complement intersected with B, and then a complement on the whole thing. So if you use this translation over here, we know intersection has to change into union. Whatever is your first set, so whatever is your first set, you end up taking a complement on that. So our unions, our intersection change to union. Now for this first set, whatever is the set, you end up taking a complement on that. For your second set, we end up taking a complement on that also. So the only difference here is, guys, your set A has a complement mark on it. Come on, pen. So the only difference is your original set A, instead of being the straightforward set, has a complement on it. So that means this set here has a complement on it too. So really, does anybody know what happens when you do the complement of a complement set? Or in logic, we had talked about the negation of an already negation.
They cancel out.
They cancel out. Yeah. So what happens is actually you end up with your original set. So here, A complement of a complement will cancel out and just give you set A by itself union with B complement. So that's actually how you're using De Morgan's law over here. So you end up with, for number 24, A union B complement. And this is what we have to now find so that we can define what our set is going to be. So the very first thing we need to do here, guys, is find out what B complement is. So if set B has 1, 2, 7, 8, 9, what will B complement have? And remember, you're looking at the original universal set to find out what B complement is going to be. So I'll give you guys, a couple seconds, a few seconds to try and come up with what B complement is. Just have your answer ready. And again, you'll share it in the chat. So look at what's part of the original B set, what's part of the universal set, and then based on that, what your B complement set should look like. So have your answers ready, and then you'll share them with me through chat. So just B complement is all you are giving me, not the final answer, just the answer for B complement. Okay, go ahead, send your answers through. Alrighty, let's see. I've got Idali 03456, Roman, Nicholas, Logan. All right, very good. So yeah, from the universal set, you can see we will need 0 because you don't have 0 as part of the original B set. We cannot use 1 and 2. So 3, 4, 5, 6. We cannot use 7, 8, 9 also because again, that's part of the original B set. So that's your B complement. What did I do? Yes, we need that. All right, so we've got our B complement now. So the last thing is now to find our A union B complement. So of course you can see our set A is right over here, 0, 2, 4, 5, 9. And then we already got our B complement. If it helps, you can write, rewrite the set A down. But what do you think in terms of set notation, what are A union B complement is going to look like? So between B complement and set A. So again, have your answer ready. And remember, you're doing a union between the two sets. So get your answer ready. And like you just did, we'll share the answer through chat. So A union B complement. Okay, go ahead, send your answers through. 0, 4, 5. I've got 0, 2, 3, 4, 5, 6, 9 from Logan. Okay. So remember, you're doing a union over here. And like I said, if it helps, go ahead and write down the set A again, so you can kind of have them right next to each other. So 0, 2, 4, 5, and 9. So remember, we are doing union, not intersection. Okay, Roman, you've got 0, 2, 4, 5, 9. So we are doing a union between these two. So you can see both of them have a 0. So we only need to write the 0 once. Now we'll see if this guy wants to work. No, he does not. So 0. Then we've got 2 in set A. We've got 3 in set B complement. We've got both of them have 4 and 5, so we can include 4 and 5 just once. Let's see, we've got 6 in set B complement and 9 in set A. So remember, union means bring everybody together, right? So whatever is in set A plus whatever is in set B complement. And if there's any overlap, you just write those numbers once. So again, you can see 0, 2, 3, 4, 5, 6, and 9. This is what should be in your union set. So Logan, 0, 2, 4, 5, 6, 9, you had all of those. Roman, looks like you were missing a couple numbers in there. And Nicholas, I think you actually went with intersection, right? Because it looks like you were looking at what was common between the two sets.
Yeah, that's what I did.
Yeah, so and you know, guys, that's honest a mistake to make. So just be careful, because union means bring everybody together into the pool, right? Just dump everything in there. Intersection means only thing what's common between the two sets. So they can definitely get a little confusing, but I think with more practice, you guys will definitely feel you know, more comfortable with the two symbols in there. So this is actually your answer for number 24. And the reason we want to use De Morgan's laws is because it actually makes your process a lot simpler. Because otherwise what you would have to do is you would first start with finding out what's A complement. Then you would take set B and find out what the intersection was going to be. So you would come up with that set first. And then you would have to go ahead and do a complement of that, which means whatever you came up with, you would have to kick that out. And then looking at the universal set, you would bring in whatever was left behind. So you can see that actually adds almost like a 3-4 step process. And then using De Morgan's law, you know, it was really about cleaning up our set, you know, without the numbers actually. So not using the numbers, but just cleaning up what our set would do. And then once you came down to this stage, you know, it was just a 2-step process. So it does simplify things a little bit. And that's kind of where we use, you know, these little De Morgan's laws to help us clear things out. So that's just an example of how De Morgan's law look like with set theory, as opposed to, you know, logic section where we talked about these the first time. I think we should have enough time to do one more example, and this one was actually going to be based on number 30. And you can see this one is talking about use a Venn diagram like the one you can see over here on your screen to shade in the corresponding region. So we had done this in 2.1 also, but now we're of course looking at, you know, 3 overlapping circles. So number 30, trying to keep the Venn diagram in picture so we can kind of have that for our reference, but here is number 30 that they're asking us to work on, kind of towards the bottom of your screen. So we have A intersect with B union C complement. So you can see how they're doing the B union C complement. So this is actually where, again, I would recommend using De Morgan's laws to kind of help you see, you know, what set we are looking at. So just using B union C complement. Let's go back to our handout here. So B union C complement is actually going to be using this first rule over here. So A union B with the whole set complemented is each individual set complement with an intersection in the middle. So if we use that translation for the second part, this will actually translate into B complement, C complement, and that union will change into intersection. So it's actually A intersected with B complement intersected with C complement. So does that make it easier or not? I'll give you guys a couple seconds to think about. Look at the 3 overlapping circles. If you have scratch paper pencil, that will definitely help you out the best. Draw your little rectangle with the 3 overlapping circles, and then see where B complement, C complement, and A intersect with each other, and what do you think will be the shaded part of our Venn diagram over here? So A intersected with B complement and intersected with C complement. And then you can either unmute your mic and tell me, or if you want to put it in chat, you can tell me that way also. Where do you shade your Venn diagram at? Okay, anybody have a clue?
Okay, I think maybe inside the A circle, but not in the overlapping sections.
Okay, so inside the A, but not the, so you're talking about this area?
Yeah, I think that's where it would overlap, but I'm not sure if I'm doing it right or not.
Okay, all right, let's see if anybody else has an answer, and then we can go over it.
I actually agree with Logan.
Okay, so you were thinking about that same area. All right, very nice. Anybody else? If you had a different or same region you were looking at? All right, so let's think about this, guys. Take it step by step. We know they're talking about including all of A, right? Because that's saying A intersected with these other circles. So let's use some color over here. So A, of course, is going to be all of this circle here, right? But then we are saying B complement. So B complement means everything that's outside of B, right? So that would, of course, mean, everything over here, as long as it was not in the B circle. So all of this area outside of B would be B complement. And then we are also saying C complement. So C complement would be everything outside of C. So again, that would be all of this universal. That would include circle A and circle B. So let's see, circle A and circle B, but nothing in circle C. So you will see the only place all of these guys come together is exactly what Logan and Roman were talking about. It's actually going to be this little area right over here where it's circle A, but does not include any part of circle B and C. So you can use, lines. You can use different color to shade, each individual part, and then see where all of them will overlap. So I'm actually going to clear this out and just show you the shaded area itself. So it's going to be right here, what they were talking about. And, of course, I should stay within the circle. It should not be going out, but that's what you are looking at for number 30. So that's A intersected with B union C complement. So technically that's A intersected with B complement intersected with C complement. And this is what it ends up looking like right over here. Nothing on the outside. All righty. So like I said, it really does help if you try to draw it out and, kind of see where all those overlapping areas are going to be. So you will have a couple examples on this one here, because again, we just want to make sure you are able to recognize, which area, you will be focusing or talking about. So you should feel comfortable, with these kind of questions. So what I wanted to do is there's just a couple other example that we need to look at, and we can do this during our next class. And this was actually based off of these blood type questions. You might actually have a similar example in here. So I wanted to talk a little bit about, just how to use set theory kind of in this blood type scenario. So we'll look at those examples on our next class. And then, like I said, that's fine, Cynthia, I'm done. And so we'll just need to finish 2.2, like 1 or 2 examples, and then we'll get into 2, 3, 2, 4. We should actually be able to finish that on Wednesday. So Friday, we should actually start talking about chapter 3. So I noticed that some of you have not started working on homework yet. Please, guys, go ahead and get started, because you're looking at exam for next week, okay? For chapters 2 and 3. So please don't fall too far behind. Work through your homework. And if you get stuck on anything, obviously let me know. All right, guys, have a wonderful day. If you want to stay back and ask me questions, that's fine. If not, I'll see you on Wednesday morning.
Thank you.
Take care. Thank you.